Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And I'm Benelli. For math homework help, call in Bakersfield 636-4357. Anywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Well, Benelli, thank you very much for taking care of that for us. And what grade are you in right now?
I'm in 4th grade.
How is 4th grade?
Good.
I think that you are so smart, and you gave those phone numbers, and you let kids know how they can get in contact with us for math help. Are you ready to go work on the phones and help kids when they call in?
Yes.
Ooh, there you go. See, I knew we had a new recruit right
Very
there.
good.
All right, so you're a seasoned veteran of Do the Math because you were here when you were in 3rd grade also. And you had enough fun that you were willing to come back and do it again in 4th grade, right?
Yeah.
Okay. So what kinds of things have you been doing in 4th grade that are brand new to you?
Multiplying double digits and long division.
And you like that stuff so far?
Yeah.
Okay. Is there anything that you know is going to be coming up that you're looking forward to?
I don't know.
It's just going to be a surprise, right?
Yeah.
Okay, because I didn't know if you had an older sister and she might be telling you kind of some of the things that might be happening or not, but you're just going to wait for it to happen, right?
Yeah.
Okay. How are you with time? Do you like to be on time? Are you usually early? Are you kind of late sometimes? Or are you always on time?
I think I'm always on time.
I think you're always on time too, right? So, yeah, I mean, you were here on time today, right?
Yeah.
So that's a good thing. How are you at telling time? If you see a regular clock, right, where the hands go around usually like you have in the classroom, are you good with that kind of a clock?
Yeah.
And are you good with a clock like this where it's a digital clock that's up there?
Yeah.
You're good with both of those. How are you with an hourglass where you turn and the sand goes through? You're like, I don't know what you're talking about, huh, old man? How are you with a sundial?
I don't know.
I'm only kidding. There's lots of... So anyway, are you ready to help me out with our social media problem of the day?
Yes.
Okay, because it has to do with time. So let's take a look at it together. So if you could, Benelli, please read that for us.
If a bus departs a terminal every 2 hours and the first bus is scheduled for depart at 10:35, what time should the second bus depart?
All right. So it's a lot of information up there, right? We're at a bus station. The bus is going to leave the terminal every 2 hours. The first one leaves at 10:35. When would the next bus depart? Do you have an idea or how to figure that out?
Sure.
Okay. What do you think?
Well, it says 10:35, so, and it also says 2 hours. So if you add 10 to 2, it'll give you 12, and then you can also add a 35. So I think the answer is C.
So you think it's C, 12:35?
Yeah.
Why do you think A is up there, 10:35? Why do you think that's even an answer up there? Any idea?
No.
Maybe because it's written in the problem. Somebody may not understand what the problem is, and they go, well, I see 10:35, I'll just put 10:35. Make sense, kind of?
Yeah.
But you're like, I don't know why it would make sense, because it's asking me a totally different thing, right? So you think 12:35 is the correct answer?
Yes.
You're willing to bet on it?
Yes.
Oh, all right, let's let it ride. Benelli says C, 12:35. Hey, nice going. First problem all done. Pretty good, huh? All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays. Time now for today's Math in the News. All right, in studio with us, we have Jamie. How are you today?
Doing well. How are you guys?
It's excellent that you were here because it's been a while since you've actually been in studio with us.
It has been a while. Yes,
because
it has.
you're now, where are you all the time now?
Well, I'm now at the Steam Yard, and we just opened up in April, and we had our grand opening. We did some trial field trips, and then we had an amazing 7 weeks of summer camp all day long. And since the school year started, we've been doing field trips and after-school programming, so we've been really busy.
I was going to say you are busy, and I know that we are able to go over to the Steam Yard and we do our science challenges over there.
Right.
And I know that we've got a couple of teams. They all seem to do very well last time, and the points are accumulating, and I know Devin and those guys are looking forward to the next time they're over at the Steam Yard with you.
And we're really excited on our next challenge. So we've got some great opportunities to add technology piece to our engineering project, so we're looking forward to next week.
So should I let anything out about that, or should we just keep it a secret?
I think we should gonna keep it a secret. Let's keep it a secret because
We'll do
with that tech
because I was
piece.
going to say a little hint out there, but
Go
since
ahead.
you said keep
Go
it,
ahead.
well, no, because you said keep it a secret, so I'm going to keep it a secret.
Okay.
All right, you know how to do that, right? You ever seen that before? Yeah. Yeah. Okay. All right. So, Steam on the Streets is coming up. And is this Steam on the Streets something that Benelli could go to with her family?
Yes, definitely. This is our second time that we've been open for the public, and we're really excited. We're open at 9, and we shut down at 11:30, and so everybody, your whole family can come. We have activities from kindergarten all the way through 8th grade.
And we can see some of the past things that are going on right there. And where are they? I mean, they're out near the Steam Yard here, near KCSOS.
So this is downtown at 17th Street at our city center. And so this year is our first year we're going to be able to have it at the Steam Yard. So we have a pumpkin patch where you can get free pumpkins if you've gone around and visited some of the activities. We've also borrowed some areas outside of the Steam Yard and some of the other KCSOS buildings. So we've got a lot of great activities.
All right. Well, I know that you brought some books, so tell us a little bit about those first.
So what we wanted to do is we want to promote literacy within STEAM itself. We, in our lab, we like to do activities or do engineering projects with them. So for example, we have counting sheep, and with counting sheep, you know, you read the story, the students will read the story, and then they'll find out that the little sheep can't get over the fence.
So the counting sheep. Now, if I read this book, am I going to go to sleep?
You might, but it might actually.
For those of you a little older, will get the reference about counting
Right.
sheep and stuff. But we have an activity that goes along with this, correct?
Right. So we at the Steam Yard have a lot of 3D printers. So we 3D print our products. So we have 3D printed some fences. We've 3D printed some sheep, and then we give the students various tactile pieces where, you know, popsicle sticks or whatever we're doing that day to engineer how you're going to get that sheep over the actual fence. But this is a little bit too easier for you, so we're going to try something different, all right?
Are you ready for
I
this,
know, I
Benelli?
saw it. Did you see your eyes, how
right.
bright they got? So what we're going to do is, in your age group, we are looking to build a lightsaber, or it could be a flashlight. Pretty cool?
Yeah.
Okay, so we're going to try that. So I'm going to give you an LED light, and this is a coin battery. Then we're going to make that on this popsicle stick. Okay, pretty cool. So this is an activity we're going to be doing at the Steam Yard, and what we want to do is we want to build up to this engineering activity. So we have basic circuits where it's old school circuits where you're connecting them to batteries and light sockets, and you have alligator clips. But this time what we're going to do is we're going to use copper tape. So copper tape used to be used in gardens to kind of shy away with all the slugs. And so we're going to actually use it for science, okay? So what we're gonna do is we're going to go ahead and, can you go ahead and peel that off? You wanna take that piece of tape off. And we're going to create a flashlight. There's other activities as we're at the Steam Yard. We have robots, we have coding. We also have an art contest that's going on, and those art pieces will be at the site as well. So what we're gonna do is we're gonna take that piece and we're going to add it onto this stick. Now this one got really curly, so that's why I kind of grabbed it from you so that we can straighten that out. There we go. So one thing about this is when you're learning about basic circuits, you want to make sure that we don't have one alligator, like the alligator wires, connecting at the top. Because what we're going to do is we're going to put our light on top. Okay? So if we do one side, we're going to have to do the other side. So you want to flip that over. All right, so I'm going to have you go ahead and put a piece all the way across. So this is a 3rd to 5th grade standard.
If you want to peel that part off, and I'll help you.
There you go.
Put it down there. There you go. I think we got.
All right, I'm going to save the rest of this.
All right.
Okay, so one of the main problems students have with when they're starting to build, and especially with engineering and science, is troubleshooting. You got to keep practicing if something doesn't work. Well, one of the ideas with this circuit is the troubleshooting is sometimes the LED, this light, doesn't work, and sometimes the battery doesn't work. So before we put it together, we want to test it, okay? Did you know there was 2 sides to a battery?
Top and
Maybe.
bottom, huh?
Top and the bottom. So there's a positive and a negative. See, we see that positive right there?
Yeah.
So there's a positive and negative, okay? On this LED light, what do you notice about the probes at the end?
One of them is taller than the other.
So that's going to tell us too, one is going to be positive and one's going to be negative. So what we're going to do is we're going to test to see if 1, the battery works, and 2, if the LED works. So I'm going to have you hold those. And what you're going to do is you're going to put that battery in between. There you go. So it didn't work, did it?
No.
All right, so what I want you to do is take the battery out, flip it around, and try it again. It works, right? Perfect. So we know that this is great, and it's going to work if we get it right on the stick. All right, so let's try it. So go ahead and take your battery off. All right, so now you're going to do the same thing you did with your battery. With your LED, you're going to do the same thing here. So go ahead and put it right on top.
This.
Yep. All right. So we have to make sure is in order for that electric current to flow, we need to make sure that the metal touches the metal. All right. So what I'm going to do is take a little piece, and I'm just going to add it on here so it can stay right there and it doesn't move. All right. You're going to do the same thing. So I want you to take a little piece, and we're going to put it on this side. Perfect. All right, so now we got both sides going. So now we got to figure out how do we add a battery, right? So what we have to do is what this is going to do is it's going to make a circuit. We need to close the circuit because right now it's considered an open circuit. So what we have to do is we have to take this battery, but we also need something to go all the way around so we can touch that side of the copper tape. So paperclip is the easy trick, okay? So we're going to see if this works. We're going to have this, and we're going to see if that lights up. All right, didn't work. What did we do the last time with the and when it didn't work?
We flipped it around.
All right, so let's flip the battery, see if that helps. Oh, so now we have to start troubleshooting. That didn't work either. So there's something up here with this connection. So if we look at this side, it's probably this side. So put that other little piece of tape right there and just go long ways.
And I think that's an important part of STEAM on the Streets is
Yes.
that the kids are going to see it doesn't always work the first time.
Right.
So troubleshooting and trying to go backwards to see what worked first, what didn't, and then you can kind of see what's happening now.
But-
What's happening?
It flashed.
It flashes, right?
Right.
It works, right?
Right.
And I think the key was making sure that you went back and just, instead of taking the whole thing apart,
Right.
going step by step like that.
Right, and that's what engineers do too. So now not only are we learning about science, we're also learning about engineering as well, and how we can engineer. And we can look at this and go, all right, my next iteration, my next time I'm going to do this, what do I need to change? Maybe I need a bigger paper clip, maybe a bigger popsicle stick. Do you think it would work?
Could get a bigger light.
Right, could get a bigger light too.
So STEAM on the Streets is coming up next weekend, October 25th, and it's free.
Right.
And once again, where is it?
This is at the STEAM Yard at 2020 K Street.
Okay, and you'll be there. You'll have a lot of people helping you.
We
There'll be a
will.
lot of kids out there. the pumpkin patch, all sorts of great activities. And who knows, maybe you'll see Benelli down there. You guys can have a lot of fun also.
Yeah, we could teach you some more.
All right, there you go. Hey, we'll be back with more right after this. Our mathematician of the day is Galois, a French mathematician known as the father of modern group theory. And clock arithmetic is an example of what is called a group in mathematics. And there are a lot of different ways to tell time. A lot of us grew up, and there still are in use, clocks with clock faces in which you need to be able to tell the time looking at the hands on the clock. So we have two different problems down here. Dr. Smith prescribed some penicillin for Josh. He's supposed to take a dose every 6 hours. If he first takes it at 7 a.m., when will he take the next capsule? So if we're at 7 a.m., and we can see if we add 1 hour, it's now 8 o'clock, okay? So we add hours, we would be at 9, 10, 11, 12, and then there's a blank because the next hour would be 1 o'clock. We can see by adding the next hour, it's 2 o'clock. So if we're at 7 o'clock and we add 7 hours, it is now 2 o'clock. AM, PM, that's up to you, whatever you want to do. But if he has to take it every 6 hours, we know it's going to be in this column right here, which would be 1 o'clock. That would be the next time he takes the prescribed medicine. Jennifer's flying north to her grandmother's home for the holidays. Her plane leaves at 9 a.m., so we can see we're going to leave at 9 a.m., and the flight takes 7 hours. So we're going to go here, we're going to add 7 hours. So we can see that here we had 6 o'clock. If we just go back, 5 o'clock, 4 o'clock, and if you just think logically, you're leaving at 9 o'clock, you're going to get there in 7 hours. So 1 hour, it's 10 o'clock, 11, 12, 1, 2, 3, 4 o'clock. So now the key is, if she leaves at 9 a.m., it's not 4 a.m., it's 4 p.m. So determining the use of this table, clock arithmetic, another one of the group theories that Galois was famous for, that is our mathematician of the day.
Did you know that 30 is a primorial? A primorial is a number that you get when you multiply a number by all of the prime numbers below it. For example, 5 primorial would be 5 times 3 times 2, and it equals 30. Now you know.
And thanks to Samuel for that. Primorials are quite a difficult thing for some people to get because sometimes they go, 5 primorial is all of the primes under 5, but then some people think it's the first 5 primes. Oh. So there's two different ways of looking at it.
Okay.
Anyway, Benelli is a 4th grade student and you're at Stockdale Elementary, correct?
Yes.
And your favorite number, I heard somebody say or something that you mentioned that 9 is a good number for you or whatever, right?
Yeah.
And why is that?
I'm 9 years old.
You're 9 years old. Well, why not? You know what? Mine's going to be a double-digit number, though. But you know what? What are you
So
laughing
is mine,
about?
11. 11
John,
is
everybody
mine.
laughing about
It
it.
adds up to 9.
Yeah. You take both of my digits and add them up, and it'll make 9. So I'll let you think about that. It could be 27. Easy, but back
Sure
there,
it
the guys are 90.
Sure it is.
Oh, easy now, easy now. I was going to go like 27 or something, 36 maybe, I don't know. Anyway, you ready to do a little work?
Yes.
All right, head on over to the board. You and Cece are going to complete a magic square. And the reason I wanted to do this is because there are 9 numbers. So what you have to do is you have to move those numbers, and they all move, so that any row going across adds up to 15. Any column going up and down will add up to 15. And when you go diagonally in either direction, it will add up to 15.
Oh,
So instead of you trying to figure out what they add up to, I'm just going to tell you they all add up to 15.
okay.
All right? Go to it.
Okay, I'm going to let you go to it. Where do you want to start? You want to start with low numbers? You want to start with high numbers?
I'll start with the low numbers.
Okay, all right. So where do you want to put a 1?
I'll put it in the middle.
Okay, can you read? I'm sure you there we go. Oh, there you go. Cool. All right, so we need to add to 15. So what can we put maybe here to add to 15, and we'll see what happens there.
A 9.
Okay. So that gives me, 1 plus 9 gives me 10. So, okay, so what's my last, box going to be?
5.
Okay, I like it. That's a start. Uh-oh. Uh-oh.
Oh,
So I think maybe Cece, instead of her trying to grab it,
Well, I'm not grabbing it either.
all right, so maybe hit the unlock. All right, that went
Okay.
away, so let's see if it,
Unlock. Yes, no, no. You
all
know,
right.
you
So I
know,
know
you
that
know
Mac
me in
is coming in here in a
technology.
second.
Yeah, so,
So while you're doing that,
'Kay.
think about where you want the other numbers
all right,
to
so
go.
if we put the 5 here, so once we figure out how to, you know, not do that and put the 5 here, what can we do then? And let's see, we want to let Mac fix it and we'll be able to do this.
So hit one of the numbers you want to drag, because the numbers won't drag.
Okay, so the group is locked.
Yeah.
So the whole thing is locked, right?
Do we need to reload and start again?
Well, you can just write
Unless
them in.
something else? Okay, okay.
And then you can
All
erase
right, okay. I like it.
and then we can put a 7 here,
You want a 7 there? Why are you thinking a 7?
because 5 plus 7 is 12, and maybe a 3 here, because
And- okay, so-
12 plus 3 is 15.
Okay, so we're kind of getting rid of all of those. Okay, so now we said 15, so I've got 7 plus 9 here though. What does that give me?
16.
Oh, we've already gone over. That's not good. Maybe can we do that?
So would you guys like a clue?
What do you think? Do we want a clue or do we want to try it one more time before
Let's
we
try
get a
it
clue?
one more
One
time.
more
All
time.
right, try it one more time.
How do we feel about the 9 being in the middle? Okay, I think you're right. I think, oh, will it let us do that? That's nice. Okay. So maybe we don't put 9 in the middle. Do we want to put it in a corner or do you want to put it like on a different edge?
I'll keep it in the corner.
Okay, all right. Well, we can do that.
And then we can try the 8 in the middle.
You want to try an 8 in the middle? So you think the 8 won't have as many problems as the,
Never mind.
yeah, that's a problem. Okay, so what do we want to do?
Maybe the 8 right here.
You want to put an 8 right here? Okay, because then my 9 and my 8 are never going to end up meeting up. Okay, that's a good idea.
We can put a.
Now here's my question to you. With my 7, no matter where I put my 7 here, no matter where I put my 7 here, no matter where I put my 7 here, I'm going to be with my 9. So that's going to be a struggle because that's already going to be 16. What if we do this so that my 8 and my 9 never meet up? Interesting. What else are we thinking?
Maybe a 6 here.
Okay, so if I put a 6 here,
It will equal 14, and then we can move our
yeah,
1 to
but
the
my
top.
9 and my 6 will already be 15 and I don't have a 0.
Why is this so complicated?
This is complicated,
Yeah,
right?
let me help you out a little bit. So
Okay.
get those numbers off of there.
All right, let's see if they'll let us move them. You want to move that 8 that way and we'll do this?
All right, so put the 4, 5, 6 in the middle.
Yep, that is all not gonna. All right, we want to try it again?
Sure.
Okay, sure.
And the thing I would probably do is try to get 15 going diagonally first,
Okay,
from the top to the bottom with that 5.
so if I'm going this way, what are some of my options for 10?
We can do 7, and we can do 9.
Okay.
So 7 and 3
if
would
I do-
work, right?
If I do my 7 and my 3, so where do you want my 7 and where do you want your 3?
I'll put the 7 right here,
Okay, and then?
and then the 3 up here.
Okay, so that gives me 15. So that one's good. We can check that one off. Okay, good.
But think about rearranging the 7 and 3, because now we have 3 and 6 going down as 9, and you're going to need another 6.
Uh-oh. So what do we need to do?
We need.
So you have the 3
we're
and
gonna-
7, I think, is a good idea, but maybe rearrange the 3 and 7.
Yeah, we're not, we're a little technology challenged over here, but we're gonna do this. So this is his suggestion, is to do this. So that we've got a 15 here, we've got our 15 here, we don't need a 6 here, we've got a 7 and a 6, which gives me
13.
13. So what do we need there?
2.
Okay, if we've got 2, uh-oh, 15.
Yeah.
How am I
So what I'm going to do is I'm going to
15
let you girls
here?
keep on working on that, all right? So you guys keep working on that, but while you're working on that, just keep in mind that at the end of it, you're going to get yourself a meal courtesy of our friends at Chick-fil-A. So keep working on that. That way you have some Chick-fil-A to look forward to. We'll be back with more right after this.
Hey, this season, math is still happening in the real world. It's everyone's favorite part of the show. We got to figure out what's going on here. So I brought my friend Corey to tell us about a super unique place that you may not even know exists here in Kern County. Corey, thanks for taking the time to be with us, man. Appreciate it. Tell me a little bit about what's going on here, what you do, and what this place is. It's Crimson, right?
You guys are here at Crimson Plant 1.
All right.
Crimson Bakersfield Plant 1, Plant 2.
Right.
It's California's largest biodiesel plant.
Okay. So we're talking biodiesel today.
Yep.
Yeah. So what's behind the biodiesel comes here, or you have some raw materials that come here, right?
Yeah, we bring in, basically these plants can run on any type of feedstock, animal fat,
Okay.
plant oils.
Right. And then you take that material that probably nobody else wants.
That's right.
And you do something and make it into a product that people do want. What do you make it into?
Diesel grade fuel.
Gotcha.
It's basically a biodegradable diesel fuel.
Wow, that's amazing. So that process is something that everyone wants to hear because you're taking basically a waste product and making something productive out of it.
That's right.
Right?
Yeah.
So real quick, how does that work? It's maybe not a real quick topic.
You want to make some biodiesel?
Let's do it. Let's go make some biodiesel.
Let's go.
So let's go take a look at what the first process is,
Okay.
right? And then we'll kind of make it.
Yeah, we'll stay on Plant 1, which is the original plant here at Crimson.
Okay.
And we do 22.8 million gallons out of that plant.
So we got to see this place.
Yeah,
All
I
right.
love it. Let's
Okay,
go. Let's
sounds
go pull a sample.
Yeah, let's go
Okay.
pull a sample, see what's going on.
Let's go.
All right, Corey, so we're at the next process here, right? And I'm still a little bit interested in what's going on here, but we have a big truck behind us and it's full of,
UCO,
okay,
which stands for used cooking oil.
used cooking oil, all right? And people probably don't want that still at the McDonald's, so they send it to you.
Exactly. So, I mean, this could have came from the streets of Bakersfield.
Oh, there you go.
Isn't that a song? I don't
That's right, that's right. And so we want to know what this stuff looks like, right?
We're gonna, yeah. Tony, you want to grab a sample?
And so probably not something we want to just drink right out of, right? This is used cooking oil, already made some French fries or something.
Yeah.
They want to get rid of it, and then as an initial product, as a raw material for
Feedstock, yeah.
you can use that to make fuel.
That's right.
Right.
He's gonna pull a sample with what we call the sledge judge,
Okay.
and we're gonna measure a few of the constituents that are in there, the impurities.
Okay.
We're gonna measure MIU, which stands for moisture, insolubles, and unsaponifiables. And then we're also gonna measure for sulfur
Okay.
and FFA.
And so you want to know a little bit about material that's coming into this facility.
We do, just to, if we need to adjust the recipe.
Right.
It's just like making cookies.
Right. And so
If we got higher FFA on a certain recipe, we could come out of the first reaction a little high on the free fatty acids and start making soaps. So
Oh,
we can easily
wow.
start making soap rather than biodiesel.
oh my gosh. So at least you have another option if the mix isn't exactly what you want it to be, right? There's another thing you can do with it, or at
Well,
least
I
another
mean,
byproduct.
we like certain blends for certain seasons, basically.
Okay.
Seasonally, we have to hit a cloud point, and cloud point is basically when impurities basically start precipitating out of the biodiesel
Oh, wow.
and can foul fuel filters and
Right, right. So there really is a pretty long process, and knowing what goes into it, exactly the materials that you're getting, is going to adjust the recipe or the
that's
cooking
right.
process.
Yeah, this is the first step.
Right, right.
So we're going to check and make sure the feedstock hits all the specs.
yeah.
We're going to take it out of the truck and put it in the feedstock farm.
Okay,
there
so
we
not
go.
so appetizing, but there's some good stuff in there.
Primo.
And is this normally what it looks like, or could it be
Oh
different
no,
colors?
it could look much worse.
Okay.
This is actually pretty good looking
This is actually,
stuff.
okay. Tony, good job. You got a good looking sample there. I appreciate that part.
Because this plant, which is plant 1, it can only handle up to a certain level of degradation. It can only handle up to like say 12.5% FFA.
Okay.
So we're going to test this and make sure that it fits all those parameters.
Gotcha. Let's do that. We know there's some more math to do back in the studio, but when we come back, we want to analyze this thing at the lab because you never know what might be in that stuff. Back to you in the studio, Mike.
All right, thanks for that, Scott. Well, we've got quite a few guests in studio with us right now. We've got Mike, Kylia, and Zach. How is everybody?
Great.
Yeah.
Nice to see you all. Thank you for coming in. We have the Civic Seal of Engagement that is going on, and that is something that the Kern County Superintendent of Schools is partnering with. And Zach, that's what your part is here.
Yes.
And then Kylia, you kind of, with a bunch of other students, came up with a problem, well, you saw a problem and you came up with a solution. And then you were one of the instructors helping the students with this at Chipman Junior High.
That's correct.
So Kylia, let's start with you because you are the brains behind this, you and the other students that were doing this. So what sparked the project that you guys came on? Like you guys saw a problem and then you figured you had to do something to solve it, right?
Mm-hmm.
So how did you get a group of kids together and go about this?
I think we just introduced the idea, and then those who were interested and saw that this was an actual problem and wanted to take action decided to participate, and it turned out to be a really good team that works together well.
Good. So this is something that KCS is involved in. So Zach, tell us a little bit about how this started and how other groups can get involved with it.
Great. Well, she just said the key word, which is taking action. So we're part of a grant that we have that promotes the State Seal of Civic Engagement available for high schoolers, but we also have a pathway available for middle schoolers. For students that want to take their learning beyond the classroom and take informed action, so things like going beyond the classroom, it's not just a worksheet, but something that's really involved in your community, something that really helps you shape your community for the better.
Okay, and Mike, you're one of the instructors that helps out with this at Chipman. Yes. And what was your role? Because you kind of like are guiding the students, but it's not really your project, correct?
Correct. Yeah, I guess I'm a curator.
Okay.
You know, I try and put information in front of the students and connect them to people in the community that are going to advise them or give them some ideas or make sure the project happens, like KCSOS.
Okay, so you found out about this from KCSOS, right?
Well, sort of.
Okay.
Yeah, we approached KCSOS for some help with a PSA and just.
Okay, so that's what I wanted to get into
Yeah,
next was the PSA. So let's take a look at what you guys did. So I think we've got some footage here, and let's take a look at it right now. So this, right, so this is KCSOS helping out, kind of filming what you guys are doing, correct? And Kylia, who came up with who's going to be doing what? How did you guys come up with all of the different parts?
So the group of students, we had, I believe, 3 main students who came up with the script, and then the students that wanted to speak, they were given lines from that script just to say. And I think everyone just went with it, and what worked, and we did it.
So everybody bought into the project, right? And what was your project? Because I know we saw that you guys working on it and things like that. You guys came up with how you wanted to solve the problem by your school, right? You wrote the script, you guys came up with everything. You got a little bit of technical help with the Do the Math people from KCSOS. But what exactly were you trying to solve?
The goal or big idea of this project was to make our streets safer for the students, the staff, and just the community, and encourage them to walk or bike to their different locations.
Okay, so Mike, you heard what the kids wanted to do. Right. So what was your role in this next? So, I mean, you're trying to guide them, the curator, kind of helping them along. And did you think this was something that was going to be doable, or did you kind of modify things for the kids?
Well, yeah, that's interesting. The City of Bakersfield, the Traffic Engineering Department, had already put together quite a bit of information about streets and traffic and things like that. And so I was able to show that to the students, put that in front of them, and guide them through the process to look at the documents. And from there, they started to develop a PSA and just an outreach approach and a whole plan that included a budget and a funding source. So just a really deep analysis.
And I think that's the great thing about this is that the students, you did everything, right? You and your team came up with everything. You wrote the script, you came up with the budget, you came up with the plan on how to solve this instead of just saying, hey, this is something that needs to be fixed. Here's how to fix it. That's what you presented to them, correct?
Yes.
So let's watch the PSA right now and see what you guys did.
Math assignment we have today?
I know, it's so difficult.
It's so hard.
Wait! One glance at your phone could be the last.
Wait up. Throw our phones away.
Okay.
Let's look both ways. No cars. Okay, let's step out.
Stay alert. Stay safe.
Your life is worth more than a text. Keep your head up and your phone down. Heads up, phones down for a safer Bakersfield.
So heads up, phones down. Is that a collaboration, or did somebody say, hey, this would be a nice little line to use?
It was just a slogan that we came up with. We thought it went along with the project and making the community safer and keeping our students safe.
So you did the PSA, and professionally done. I mean, you guys did a really nice job on that. And you guys kind of practiced it a little bit, went over your lines and who was doing what and things like that. So it came together beautifully. But then you actually presented this to the city council. So I think we've got some footage of what's going on there also. All right, so there you guys are doing this with the city council. And do you think they took you seriously when you went in with this?
I definitely think they took us seriously because of the way we presented ourselves. We weren't joking around. We were really taking this seriously because it's a serious issue within our community.
Right, and I think that's the important thing is you guys took ownership of it. And even though you're a student, they needed to see that you guys were serious about what you were doing. You're presenting yourself well at the city council. And when they did that, when you guys did that, I'm sure you were a little bit anxious, you know, like going in front of a bunch of adults trying to say, hey, this is a problem in our school. We see what the solution can be, and we need your help in implementing this, and this is what we want you to do it, right? And I know you've got a lot of friends and students and helpers that helped out with this thing, so I know that we can take a look at them right now. Let's see where they are downstairs. Hey, there they are. Hey, there you go. So that's not even everybody involved, but that's a lot of the kids that are involved, right? So nice to see that they were able to come out and support you guys. And you know what? I mean, you should just be commended. This is just an absolutely beautiful thing that you guys have done. You saw a problem at your school. Mike, you guys helped them out with the help of KCSOS, the Civic Seal of Engagement, and then these are some chords that kids can do before they're in high school and getting that seal on their diploma.
Absolutely.
And this is for the junior high school.
The red, white, and blue is for the middle schoolers as they develop their skills of civic engagement, and the green, gold, and white is for elementary school pathway we have just recently opened. So that way when students get into high school, they already have some skills in civic engagement and some ideas in taking informed action in their communities so they can be better involved students and citizens in high school.
All right, well, Zach, thank you for the program that you guys offer. Mike, thanks for helping curate and help the students with that. Kylea, thank you especially to you and your classmates for coming up with that idea, implementing it, and just outstanding work right there. And if you want to find out more, we'll have more on our website so that other students can do the same thing. We'll be back with more right after this.
Hey, we still got some math in the real world happening, and of course, this beautiful product here is what we started with. We just dipped some out of the truck, right? And we want to know what happens and how they clean this stuff up. So I brought my friend Thomas. Thomas, thanks for taking the time with us.
Hey,
appreciate it, man. What happens in this place? Because it looks awfully official.
So over here, we're going to be testing the front line. So any truck that comes in, we want to monitor specific test points, essentially, so we can produce the best quality fuel we possibly can.
Right.
We do have certain limits for those fuels.
Right.
And so basically, as you can see from this bottle, this is a representation of what a collective amount of trucks would look like within our plant. So this is what we are starting with.
Right.
Now,
not so clear and not so clean.
Not the prettiest. But when we actually do clean it up, it actually comes out to a nice little oil color with no water, no sediment.
Right.
And so this is what we ideally want to start reacting with. Okay. Now the reaction is a esterification process, where essentially on the fat molecule, you're just doing surgery and removing part of that molecule and reattaching the ester group onto it. And that's how you produce the biodiesel molecule. And so this reaction right here that you're seeing is actually in half. So the top layer will be distilled biodiesel and the bottom layer will be distilled glycerin.
Oh, okay.
And this is crude. This is before anything is cleaned up. So this is still rough in process reactions.
Okay.
Now, however, when we go throughout the reaction process, these are our final products. to where we have this nice clear biodiesel that came from this kind of feedstock.
Wow. So there's definitely a big, long process that goes through here. So in this building, what do you test for? Like, what? So for instance, what happens over here?
Actually, this isn't necessarily a test for like the main parts of the fuel. This is actually a reactor system where we can test for specific feedstock and just do a rough reaction to see how it would actually simulate in the plant.
Oh, okay. I gotcha. That makes sense. All right.
The test points that we would test for would be for the standard for ASTM D6751. Now, there's quite a few test points that we test the fuel for.
Yeah.
One of those will be at this station right here.
Okay. And what happens
this
over
station
here?
right here is where we would test for cold cell filtration.
Okay.
Now, in cold weather climates, diesel can freeze, or biodiesel can freeze. So basically from that, we basically hold it in a cold hold and we warm it back up to make sure those cold impurities are still there, and then we filter it. What it's essentially doing is taking a fuel filter and simulating what a fuel filter would be in an engine.
Right.
And to see if the fuel will pass through the filter with no restrictions.
Yeah, that totally makes sense. And you want to be able to conduct those tests here before
absolutely.
it gets to the point where a vehicle is trying to run on that fuel and get stuck somewhere and they say, hey, it's this bad fuel, it doesn't do what we wanted to do.
Yeah, absolutely.
Yeah.
We certify every lot before it even gets pushed to even be available to sold.
Right, that totally makes sense. So a lot of testing going on here, a lot of figuring out what's happening as far as before it goes out the door.
Yeah.
What else? What else do we have over here? Because I know that we brought our friend Martha. Martha, what is going on in this area here? Because it looks awfully important as well.
Yes, so this is actually the most important machine that we have here.
Okay.
And this one, well, I consider it one of the most important ones. And this tests acidity as well as soap content. So here we have two different chemicals, and one is an acid and one is a base. And the way that we titrate an acid, so what we do is we measure acid by doing titrating with the opposite.
Right.
And we'll titrate it with a base because the opposite of a base is an acid, and when you put them together, you get water and salt.
Okay.
And so it'll spit out a number that will give you an acidity. And the way that we titrate it here is we have these two chemicals. We have KOH, which is potassium hydroxide, and HCl, which is hydrochloric acid.
Okay.
And we load up our samples here. And the reason that we test the acid through every single stage of the process here is because you don't want the acid to corrode your engine, your pipes. You don't want it to damage your car. And so it's very important to also quantify how many soaps we have using our dilutions and using the chemicals that can cancel out. So for example, base will cancel out an acid.
Right.
And so as much base as I use, if I use 1 milliliter of base and it neutralizes that acid, that means I have 1 milliliter of acid.
That totally makes
Yeah.
sense.
So
So
the
from
more
that raw
acid-
material,
Yeah.
right, we're bringing it in here to figure out what is actually in there, how the tests are going to run, make sure that the product that you're going out with is going to be a good one.
Yes.
And we want to make sure that we see what the rest of that process is after that happens here. Thanks for your time.
Of course,
Because this
thank
looks like
you.
a really interesting place. At the moment, we know we have some more math to do back in the studio, so Mike will be back in a bit.
All right, Scott, thank you for that. We have Benelli, a 4th grade student working on the magic square because 9 is her favorite number because she's 9 years old. A lot of different ways to solve a magic square when you have 1 through 9. And I think Benelli has come up with an idea to solve this one right here.
Yep.
So
She
explain to us and show us how to
She
solve that.
decided she knows where the 7 goes because we need the 9 and the 8 and the 7 to not be lined up at all. So go ahead and move your 7. Okay, nice. And from here, you can just go ahead and finish her out. Go ahead and tell us where you're moving things.
Okay, I'm gonna put the 2 on top of the 9.
Okay.
And then the 3 right here.
Okay.
And then the 6 on top of the 1.
I think that looks pretty good. If we just go ahead and add everything this way and add it that way and add it this way and that way, it's all 15s.
And all sorts of different ways.
Yep.
All right, nicely done. So that was a little bit of a struggle, right, to kind of find that solution, right?
Yeah.
So right now I'm going to have you struggle some more. So Cece's going to bring up another screen, and this is a program called Struggly. And what do you think you have to do with it? Struggle.
Yeah.
Right, that's why it's called Struggly. There are no directions on what you have to do. You have to figure out what to do. But because we've been doing a lot of problems with time, we're going to do this one right now.
Okay.
All right? So rock around the clock there, Benelli. You and
Okay.
Cece go to it.
Just kind of touch some things and see what happens, and we'll figure out what it is we're supposed to be doing. Oh, cool. Okay, nice, nice. All right. Now, Keep in mind, I've never seen this either, so I don't know what to do. So let's just go ahead and like, we'll go around and see what happens. Maybe go all the way around once and see what happens. Ooh, interesting. Let's just press done and see if they tell us what they tell us about that. Oh, rotate around again. Okay, so try again. Okay, 12 p.m. she says. Go ahead and say done. Oh. But I'm not quite sure what we just did there, but apparently they liked it, so let's figure it out.
So maybe instead of going all the way around,
maybe we're trying to do this.
there you go.
Ah.
So see if you can.
Okay, so let's see what happens now. Go ahead and move your thing and see if we can't do this. What does that even say?
6 a.m.
6 a.m. Okay, so let's go ahead and go. Okay. Okay, so now that's starting to get to like a nighttime kind of scene looking thing. So maybe let's go
around one more time.
Sure, let's see what happens. Okay, so nighttime happens and then we're morning. Okay, so go press done and we'll see what happens. Hey,
So you're going based on the background color, correct?
Oh, there was like the moon and a sun.
Okay, right. So you're seeing those objects move. Okay, good. All right, I was just wondering what you were coming up.
Okay, all right, so let's go ahead. See what you think. Okay, so my sun just set. My moon is rising.
8 p.m.
Okay, I like it. Go ahead. We'll see.
Says exquisite.
Exquisite. Okay, do it again. Let's see what happens.
7 p.m.
Okay.
8 p.m.
Okay, so I think we got the hang of this one. I think we're doing pretty
So
good.
go again. Let's see. I want to see where you're at as far as your levels go.
Okay,
So
go ahead. Go
keep
ahead.
going there,
We're going to prove to him we know what we're doing. I say we, you. What? Okay. Okay. Let's see what this is. Okay, it liked us.
Keep going. Why do you think they have the other numbers on there, Benelli, other than 1 through 12?
Why do they have the 5 and the 10s and all that kind of stuff?
It's 5 times every number.
You're right. It absolutely is. Yes. But so we know that that there's 5 minutes for each, right, to get around to 60 minutes. What's special about 60 minutes?
It's 1 hour.
1 hour. Nice. Okay, so let's do 2 a.m. and see what happens. Okay, and we're right. Because see, it's starting to get kind of picky with us because it's starting to do maybe minutes, but let's go ahead. It hasn't asked us for minutes yet. But I bet it will start asking us for minutes at some point.
So keep going. You're on a roll. Let's see how far you can go. I'll give you 1 more minute to see how far you can go with that.
Okay, go fast. We're going to go as fast as we can.
Okay.
Go fast.
10:30.
Oh, struggle. Okay, we got this.
Here we go now.
Here we go.
I think we have to go one more time.
Okay, so you knew that because why? Because it needs to be a.m. A.m.'s during the day. Okay, keep going, keep going. Get to the 10:30. Go to the 10:30. 10:30. So that's 10 o'clock though. I need 10:30. We need some minutes. Nope, that's 9:56. I need 10:03. I need 10:30. Keep going. That's 4, 5, 7, 10. Keep going, keep going, keep going. We need to get all the way to my 30. Oh, there it is. Oh. Maybe you can you touch the minute hand maybe? Let's see if it, yeah, there we go. That's it, makes it easier. 10:30. Okay, I like it. There we go.
That one was a little
Yeah,
harder.
see, now we got to those minutes. Try one more.
Yeah, okay. And so 4 a.m. Where, but my son's starting to come up. And then, okay, I like what you're doing there. Get to the 4 and then do the minute hand.
So you're doing pretty well with this, Benelli. Do you like this game?
Yeah.
It's fun, isn't it, right? Even though it's just like a clock and trying to show the time. right? It's showing you the digital one, right? And you're doing it where you have to move the hands. And it was easy with the whole hours, but now you've got minutes. So let's see if you can finish that entire level in the next minute.
Okay, go quick.
Keep going. You're on a roll.
Keep going quick. 1 a.m.
Wait.
There you go. There you go. Okay.
So you're getting close to the bottom of the bronze there. I think if you do it one more time, you'll be right on that.
9:30. There it is. I love it. Hey.
Oh, there you go. So you got up to the 4th level now. So do you want to try one more just to complete the first one on that level?
Yeah.
All right, go for it.
9:30 p.m. Sun sets. It's starting to get nighttime. Is that your bedtime, 9:30?
Probably.
Okay. There we go. There.
Nicely done. So I didn't hear what you said. Is 9:30 your bedtime, or is it before or after that?
Probably before, or maybe the same time.
Okay. Well, you know what? I mean, man, he goes to bed, a little bit early too. The 1 o'clock is not any good anymore. So did you have fun with that?
Yeah.
So come on over here for a second, because I want to ask you some questions about that. So when you are in your classroom, what kind of a clock do you have in your classroom? Do you know what kind it is?
It's
Like the one with
like
the hands on it?
Yeah.
Okay, so an analog, right? So that's what people would sometimes say is like an old-fashioned clock, right? And a lot of times, so the watch that Cece has on is just like that, right? And I'm sure you've seen smartwatches where, see, mine is like that also, but it doesn't even have numbers on it, right? Just based on where the hands are, you can tell what time it is, right? So doing something like that helps you, and then also helps you with taking a look at it 2 different ways. But remember, struggling. If you could do that in class all the time, different kinds of games like that, would you like to do it?
Yeah.
All right, well, you know what? We'll see what we can do about getting that in your classroom sometime. We'll be back with more right after this.
Hey, we're back to math in the real world, and good thing it's nice and quiet here, Corey. We'll definitely be able to hear what's going on. So we've seen your raw materials coming in, and we've seen what happens in the lab and what they look for.
Yeah.
And at the very end, what are you producing?
We'll see how good you did.
There you go, see what happened there. Look at that. And this can be used to fuel a vehicle, right?
Yeah.
And get it on down the road.
Yeah, that's right.
Not exactly like regular diesel fuel, but biodiesel fuel.
Well, actually, a lot less. It's all about the lowest carbon fuel wins.
Okay.
This is a 78% reduction in carbon.
Right.
And that's why we're here.
Yeah.
California Low Carbon Fuel Standard.
Yeah.
And that's what it's all about.
Sure.
So while we're in the process, we can talk about the last sample that we got.
Sure. The last sample had a lot of stuff in it.
Yeah.
And then you were telling me earlier it goes to a storage area, but then you got to clean it, right?
Yeah. So that
it comes over here.
Yeah. So that sample that we took.
Yeah.
We wanted to test for the impurities. It looked good.
Yeah.
So we sent it back to the tank farm.
Okay.
And now it just goes through the process.
Okay.
And this is what we call stage 1 and stage 2.
Okay.
And we're basically centrifugally using these disc centrifuges. We are centrifugally removing out the solids,
Right.
the solid impurities. And then over on skid 2, at the flash vessel right there,
Yeah.
we're flashing off the water.
Yeah.
So we get a complete reaction.
Right.
And then from there it goes into this tank over here, which is a storage tank.
Right.
And then it just goes through a series of reactions. We have the acid esterification reaction, and then the transesterification reaction.
Oh my God.
And from there you basically have methyl esters, aka biodiesel,
Yeah.
and glycerin.
Gotcha. So that's where the whole process comes from. Your stuff, you have to take out the impurities, and that's solids and liquids and water. And so that's what this part does. We also want to see the future. So before we let you go, let's go see what happens.
You ready
where
for the
this
future?
whole thing is. I want
You
to see the
ready?
future. Let's
Okay,
see
let's
it.
go.
All right. Well, Corey, here we are. We're at the top of the future, man.
You made it.
And the product is a little different than before, right?
Yeah.
Look at that. A little bit more clear, right? And
Oh,
so
it's like mountain spring water.
this is what really you're shooting for in the end,
Yeah.
right? This is what the new process is going to do.
And that's what it's all about, is just taking the most degraded feedstocks
Yeah.
and turning it into highest grade fuel that we can,
Highest
and also the lowest carbon.
Yeah. And you use higher temperature and higher pressures to do that, right?
Yeah,
Yeah.
high
Gosh.
pressure, high temperature.
I have learned so much today. Thanks for allowing us to be here today. We want to present you with the famous Do the Math tile. Maybe you can find a place in the plant for that somewhere.
All right, love it.
Thanks so much for allowing us to
Yeah.
be here. Man, what an amazing place where they make some biodiesel and again, top of the future. You never know what you're going to learn on Do the Math. All kinds of things happening here, but we also know we got to wrap up back at the studio. So Mike, we'll head it back to you.
All right, thank you, Scott. You never do know what you're going to learn here on Do the Math. A lot of things we learn every single Tuesday and Wednesday. Benelli, a fourth grade student, is in studio with us, and that was a pretty cool game on Struggly, right?
Yeah.
Rock around the clock? There you go. You ready for a little more work?
Yeah.
Head over to the board. Because I know earlier you said that in fourth grade you're working on double-digit multiplication. So I'll have Cece write the problem down for us, and then you're going to solve it. So Cece, let's go with our favorite number on Do the Math, 23.
Okay.
And Benelli, you're 9 years old, so what year were you born?
2016.
So let's go with 16. So if you could please explain to Cece how to solve that problem.
Okay, go ahead, go to it. I'm going to leave you to go and talk me through it and write on the board.
So 3 times 6 is 18. So we'll put our 8 here and bring our 1 to the top.
Fantastic.
And 6 plus 2, 6 times 2
Nice
is
catch.
12.
Okay.
And 12 plus 1 is 13.
Beautiful.
Now we're done with our 6, so we add a 0 under.
Okay, good, because we're done with our ones place, right?
Yeah.
Good, okay.
1 times 3 is 3. And 1 times 2 is 2.
Fantastic. Okay.
Now we have to add our partial products.
Perfect, okay. Our partial products, I like that, so fancy. So very professional. Okay, continue to, go ahead and add.
So 8 plus 0 is 8. 3 plus 3 is 6, and 2 plus 1 is 2.
Try that one more time. 2 plus 1 is?
Oh, 3.
There we go. Awesome. So our final answer is?
368.
Lovely.
Nicely done. So I'm glad that you were able to go through that and show Cece exactly how you work on those. And guess what? If you do a multiplication problem like that, do you know how many other ways there are to solve that?
Yeah.
How many?
3, I think.
3? I know there's at least 3 different ways that you could solve that. So what I want you to do sometime during the next year, think about at least 1, 2, or 3 different ways to solve that problem differently than the way you just did it. Sound like a deal? All right, come on over here real quick. You know what? We want to once again thank Chipman Junior High and the students for coming down to do the math today. There they are right there. Gave us a big wave, earning that civic seal of engagement. That is awesome. They found a problem at their school. They came up with it on their own, how to solve that problem, presented it to the city council, and now we'll just wait and see if everything happens to fall into place and everything works out well with those guys. So you're now an ambassador for Do the Math. You know what that means?
No.
You have to inform other people about Do the Math. You can do that?
Yeah.
Are you a master of that?
No.
You haven't even tried it yet. Or do you already know about those?
I already know about
What
them.
is this?
A Rubik's Cube.
But this is a Do the Math Rubik's Cube. Don't you think it'll be a little bit easier?
Maybe.
Maybe, right? But you're going to struggle with it a little bit?
Yeah.
All right. So here's your LED light that you made earlier, right?
Yeah.
So remember, right? So that's yours. You hold on to that, right? There you go. So you can make it light up, right? So did you learn a little something today?
Yeah.
Good. Did you have fun today?
Yes.
That's the most important thing. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.